The next term is equilibrium. As per Newton's first law of motion, an object stays at rest when an unbalanced force is not acted on them. An object stays in motion when an unbalanced force is acted on them. Similarly, the structure will remain at rest when there is no force acted on the structure. If there is an unbalanced force which is acting on the structure, then the structure will tend to move. So this is the concept behind equilibrium. Structure or one of its member is in equilibrium when it maintains a balance of force and moment. That means the external loads and internal forces developed in the structure should be in equilibrium. Structures are stable when all of their parts are in a state of equilibrium. A structure will start to move when the absence of equilibrium. So you have to understand this concept clearly. Equilibrium means the externally applied load and internal forces developed in the structure should be same. Next, let's look into the equilibrium equations. There are two types of equilibrium equations. One is two-dimensional, another one is three-dimensional. In two-dimensional, we'll be having the equation as summation of forces is equal to 0 and summation of moment is equal to 0. Summation of forces, summation of fx is equal to 0, summation of fy is equal to 0. Since it is a two-dimensional and we have moment is equal to 0. So only 3 equations are available in two-dimensional. When it comes to three-dimensional, we will be having 6 equations, 3 equations for force and 3 equations for moment. Summation of fx is equal to 0, summation of fy is equal to 0, summation of fz is equal to 0. Similarly, summation of mx is equal to 0, summation of my is equal to 0, summation of mz is equal to 0. As per the equilibrium equation, external loads and internal forces developed in the structure are balanced. So this is the equilibrium condition. Let's have a simple example. In this beam, there is an externally applied load. So because of this externally applied load, we will be having the internal reactions. So this support is called hinged support and this is roller support. So due to this hinged support, we'll be having two reactions, horizontal reaction as well as vertical reaction. And for this roller support, we'll be having only vertical reaction. So here what we have to do, we have to apply the equilibrium equations here. What is our equilibrium equation? So here there will not be any moment since we don't have the fixed support. So we'll be having only forces, summation of forces are equal to 0. So that we have to do here. So RA, this let's keep it as A and B. RA is the reaction here, RB is the reaction here. So RA plus RB is equal to 30. This is the internal forces and this is the external applied load. So if you see, internal reaction is 15 here RA and RB is 15. This is the externally load, total load. So that is 0 now. That means the downward forces and upward forces are getting cancelled each other. So now this is a balanced structure and external loads and internal forces developed in the structure are balanced. That is vertical force. Next, coming to the horizontal force, HA is equal to 10. So here externally applied load is in the right direction. So that is positive and left direction is negative. So always you have to keep the sign conversion, right positive and left negative. So 10 minus 10 is equal to 0. So horizontal forces are equal to 0 and vertical forces are equal to 0. We have applied the equilibrium condition and both external load and internal forces developed in the structure are balanced here. To analyze the plane structure or two-dimensional structure, we use two-dimensional equilibrium equation. To analyze the space structure or three-dimensional structure, we use three-dimensional equilibrium equations. Now, the query will come to you all that whether all the structures can be analyzed by using these two-dimensional and three-dimensional equilibrium equation. The answer is no. We cannot analyze all the structure by using these two-dimensional and three-dimensional equations. Let me tell you, there are two types of structures. One is statically determinate structure and another one is statically indeterminate. Statically determinate structure can be solved by using the equilibrium equations. Statically indeterminate structure means the number of unknowns will be more than the number of equilibrium equations. That kind of structures cannot be analyzed using the equilibrium equations. Then how would we analyze those kind of structure? There are some other methods like moment distribution method and slope deflection method and so on. There are many other methods are there to solve the statically indeterminate structure, but they are time consuming and also complicated one to solve manually, to analyze the structure manually by using these kind of methods. So that is why nowadays the software come into picture where it solve all kind of statically indeterminate structure without any hassle.